everyone, welcome back to my channel Saisha. This is Amok Kaliwa. If you are new to my channel, please like, share, comment and subscribe my channel and press the bell icon for the latest updates. In the last video, we understood different polynomial equations, the concepts of maxima and minima in polynomial equations, thereafter derivation of maxima and minima using calculus, and implementation of maxima and minima on an example. In today's video, we will be understanding on the concepts of gradient descent, how gradient descent works to find the minima, thereafter what is learning rate, importance of learning rate, and we will conclude the video with different types of gradient descent. In gradient descent, gradient refers to the derivative. Gradient descent, it is an optimization algorithm which is used to find the value of the parameter. In case of model, parameter refers to the coefficients of the model of a function that minimizes a cost function. Here, minimization of the cost function means minimization of the error between the actual and the predicted. Now what does gradient descent provides us? It provides us the vector that points in the direction of the greatest increase of a function. In simple terms, it provides us the vector to move in a direction of least error. Now let us understand the mathematical derivation of gradient descent. To derive a generalized mathematical formula for gradient descent, we are going to utilize a quadratic equation which is represented as f of x is equal to a into x minus x0 the whole square plus b into x minus x0 plus c. To identify the slope of the curve, we take the first derivative, and to identify the critical values, we take the second derivative of the function. The first derivative and the second derivative of the function is represented as first derivative, which is equal to 2a into x minus x0 plus b, and the second derivative is 2a. Now, to identify the critical point, we equate the first derivative to 0. Equating the first derivative to 0, that is 2a into x minus x0 plus b is equal to 0. Rearranging the terms for critical point is x critical is equal to x0 minus b by 2a. Here, critical point means the minima or the maxima of the function. In our current scenario, we are finding the minima of the function, which can be represented as x0 minus first derivative divided by second derivative. This formula can be generalized as the next point is dependent on the present point minus alpha, which is the learning rate, into the first derivative of the equation. This is how a generalized gradient descent formula looks like. Now let us understand the gradient descent using diagrammatical approach. To understand the diagrammatical representation of gradient descent, we are going to use a cubic equation, which is represented by mathematically y is equal to x cube minus 2x square plus x plus 3, and diagrammatically as shown here. We are also considering the derived generalized gradient descent formula, which is the position of k plus 1 is equal to the position at k minus alpha, which is the learning rate, into the first derivative of the function. Always gradient descent starts at a random point. Let us consider a random point on the curve. At a random point, we calculate the slope. This slope is represented by delta of f. With a learning rate, that is alpha, we calculate the next position, that is x of k plus 1. Consider we move to the next position. Once again, at the k plus 1th position, we calculate our slope, and with the help of learning rate, we move to the next position. This continues until we reach our minima. This is how, in an iterative manner, we reach our local minima. At a local minima, the derivative of the function is 0. Hence, that is the finalized value. Now, let us understand what is alpha, which is the learning rate, and the importance of learning rate. Learning rate is an important factor of gradient descent algorithm. Now, what is learning rate? Learning rate, it is a tuning parameter of the optimization algorithm, which helps us to determine the step size at each iteration when we are moving towards the minimum. Let us understand the importance of learning rate with 3 cases. When the learning rate is optimal, when the learning rate is small, and the learning rate is large. If the learning rate is optimal, then the learning rate helps to reach the minima sooner, and also the loss to epoch function is quicker, which can be represented as a good learning rate. If the learning rate is small, then the number of epochs which we require to reach the minima is higher in case of small learning rate. Here, the loss to epoch function can be represented as bit higher. If we consider the learning rate large, then the learning rate overshoots the minima and we never reach to our minima. This can be represented in comparison of loss to epoch ratio as this. In the case of large learning rate, we never reach minima. In case of small learning rate, it takes more number of epochs to reach the minima. In case of optimal learning rate, we reach minima at a very shorter time. For a better gradient descent algorithm, we should choose optimal learning rate. Now let us understand the different types of gradient descent. There are 3 different types of gradient descent: batch gradient descent, mini batch gradient descent, and stochastic gradient descent. Batch gradient descent, we process all the training examples for every iteration. If the number of training examples are large, then batch gradient descent is not the optimal choice. Mini batch gradient descent, we randomly shuffle the data and subset certain number of training examples for processing in each iteration. Stochastic gradient descent. In this, we process one training example per iteration. In stochastic gradient descent, the number of epochs are higher as the number of training examples are large. If the number of training examples are large, then mini batch gradient descent is the optimal choice for selection. This is how a gradient descent algorithm works. If you like my video, please like, share, comment and subscribe my channel. And press the bell icon for the latest updates. Thank you.